It's one small step for man, one giant leap for mankind.
At the centre of our solar system lies a star we've named the Sun. Estimates worked out through complex observations have the Sun's age at somewhere between 4.5 and 5 billion years old. It is theorised a supernova, the incredulously large explosive death of a giant star, launched a super powerful pressure wave directly into a huge cloud of hydrogen, causing a cosmic storm of gigantic proportions. The hydrogen cloud began to spin wildly, becoming more and more compact as it began to rotate, eventually building so much pressure it initiated the fusion process. In no time at all, the huge hydrogen cloud had begun to transform into a large incandescent ball of plasma, radiating its energy, mostly in the form of light, ultraviolet and infrared radiation, and thus providing the most important source of energy for life on Earth. The process of fusion creates this energy. Atoms of hydrogen are fused together, and when 4 of these atoms fuse together, a helium atom is created. Strangely, the helium atom is lighter than the 4 hydrogen atoms that created it, as it has less mass. So where is the missing mass? Well, this is easily explained. The missing mass has been converted into energy, and this is how the sun works, creating energy and spitting it out into the solar system. The sheer amount of force created by the fusion process wants to tear the sun apart. However, its enormous mass creates gravity, which fights back and holds it all together. It is said 5 billion years from now, our star will have well and truly entered its end days. The hydrogen will be spent, and its helium stores will become its fuel. As the helium begins to fuse, so the sun will expand considerably, turning red and growing beyond the orbits of Mercury and Venus, literally swallowing both planets up and vaporizing them. Some of us believe at this point that, as the sun will have lost enormous amounts of mass due to the fusing of all its hydrogen, the Earth may be spared, as the gravitational attraction between the two objects will have lessened. Add to that the increasing heat, and we may well find our planet drifting and even being pushed away from the clutches of the rapidly growing red beast. That said, it's of no consolation to us, as life in any guise would stand no chance of escaping and would have been extinguished long before that point. Going back to the start, as the sun burst into life, it created a vast cloud of gas and dust, which later coalesced to form the planets: Mercury, Venus, our beautiful blue marble Earth, Mars, Jupiter, Saturn, Uranus and Neptune are the 8 planets, in order, as we move away from the sun. And we can't forget the many minor planets, including everyone's favourite, Pluto. The enormous gas and dust cloud also formed the moons, the rocky bodies in the asteroid belt between Mars and Jupiter, the millions of icy objects which make up the Kuiper belt, and all the comets in the Oort cloud. We will learn more about both belts and the Oort cloud later on in the series. The first 4 planets from the Sun are known as the rocky planets, and they reside in what is known as the inner solar system. The next 4 planets are known as the gas giants, although Uranus and Neptune are also known as the ice giants, just to throw in some confusion. Regardless, these 4 reside in what is known as the outer solar system. The moons of the solar system are far too numerous to mention individually, though we will discuss them further in a later episode, exclusively devoted to them. Back to the sun, the power source of all life, sited at the heart of the solar system, as I explained earlier. At a distance of, on average, 93 million miles, or 150 million kilometers from the Earth, we call this distance 1 astronomical unit. The sun's circumference is 2,715,396 miles, or 4,370,006 kilometers, and its diameter, how wide it is roughly 865,000 miles, or 1.392 million kilometers. For reference, you could line up 109 Earths in a row across the face of the sun, and it would take 1.3 million Earths to fill it up if it was an empty vessel. The Sun is so big, it actually represents 99.8% of the solar system's total mass.